Hi there everyone and welcome back to NTE. So I got a request recently to talk about graph interpretation, right? So this is going to be the first video, right? I'm going to try to keep these videos quite short, right? We are going to basically practice graph interpretation and I want to do so using a range of different graphs, right? So first of all, matriculants, what I want you to notice is that graph interpretation is going to be different from situation to situation, right? But basically what your examiners want you to know, right, is the following basic, right, conditions that you need to be familiar with, okay? And usually when you have these conditions, the x values that they're asking you to state, right, those can be taken directly or found directly from the sketch that's given to you. Sometimes there is something you need to calculate, right? For example, maybe you might need to calculate that exact coordinates where your two graphs intersect or something like that, right? But basically the whole point of graph interpretation is for us to be able to find the answers, right, from the graph itself or otherwise through algebras in some way or another. Okay. Right, but anyway, when we're looking at the conditions of graph interpretation, right, these are the following conditions that your examiners want you to know, right? The first one is simply just asking you to find where f of x is greater than 0, right? And whenever they're asking you for this, they want you to know that they're basically asking you to find the interval, right? And by interval, we talk about the range of x values, right? Where your function f, right, or whatever your function is called, okay, is above the x-axis, right? So greater than 0, right, just means that we want it to be above the x-axis, okay? Right, and in contrast to that, right, if they say f of x less than 0, right, we're looking for where is that function, right, below the x-axis, okay? If we are talking about f of x equal to g of x, then obviously you now have two functions on the same Cartesian plane, and you're basically looking for the x values where those two graphs meet, or we say where they intersect. Okay, so this is basically also where the two graphs meet. Okay, and we're always talking about the answer over here, right? Is always going to be x values, right? There's going to be either an interval of x values, right, or just a specific x value or a specific group of x values, right, where your two functions meet. Okay. And then sometimes you can have f of x less than or equal to g of x, right? So with this one, there's two conditions that they're looking for, right? First of all, if we're looking for f of x less than g of x, right, then the first thing you're looking for is where f of x lies below, right? So below g of x, right? So that less than comes from that first condition over there, right? And then after that, okay, you are looking at the equal sign, right? So after that, you're also looking for where f of x equals g of x, so in other words, where f of x intersects g of x, right? So there's two different conditions that you're looking for over there, right? Okay, and then you're going to have f of x greater than g of x, right? So this should make sense by now. You should see the pattern. We're looking for where f of x lies above, right, above g. Okay. Right. And then sometimes you can have this situation where they say f of x equal to g of x, sorry, f of x minus g of x is equals to some value k, right? And for this one, they're basically just looking for, right, the distance between your two functions, right? So with this one, basically just focus on the y values that you know, okay, because it's usually just going to be a vertical distance, right? So that vertical distance is going to equal to this specific value k, right, whether it's 2 or 3 or whatever it is, okay? All right. And then sometimes you can have these complex situations, right, where we have f of x times g of x or f of x divided by g of x or something like that, okay? So when we're looking at f of x times g of x being greater than 0, right, we're looking for the condition where our output is going to be positive at the end of the day, right? So that means that it's either f will be positive, in other words above, right, the x-axis, and g will be positive, right, in other words above the x-axis, right, because this product is going to be greater than 0, right. So that's what they're stating over here, right. You're basically looking for where the two graphs are either, first of all, above, right, at the same time, right, so where the two functions are above the x-axis at the same time, or where the two functions are below the x-axis at the same time. So if they're below the x-axis, then obviously f of x will be negative for that interval, and at the same time g of x will be negative for that interval, right. So then these two products, right, are both positive, okay. So then we basically summarize and say that for this condition, we're looking for where the two graphs are either above or below the x-axis. And the key thing here is that it's at the same time or for the same interval, right? Okay. And then in contrast to that, right, you can have f of x times g of x being less than 0, right? So for this one, I don't even want to read this condition. You should be able to understand by now that this one is just going to mean that you're looking for where the graphs are on opposite sides, right, of each other at any given time, okay? So it's either f of x is above the x-axis, right, so it's positive, and then g of x for that same interval is negative, right, or the other way around. It's either f of x will be negative and then g of x will be positive, right. You can see that these two products at the end of the day will end up being overall negative products, okay. All right, so yeah, that's basically the basics of graph interpretation, right. These are basic conditions that they want you to know about, right. These can get even more complicated, right, by telling you that h of x is some function of f that's been translated by a certain amount of units, and then only from there, from considering the translated graph, right, your f of x, your h of x function, sorry, then do you actually have some condition that you're going to be looking for, right. So together with these ones, with the multiplication, sometimes you have these ones where you have the division, right, so f of x divided by g of x greater than 0, right. Same logic applies, right. You're basically going to be looking for areas where if you want it to be positive, then obviously it's either you're going to be dividing a positive with a positive, right, so in other words both of them are above the x-axis, right, or you're going to be dividing a negative with a negative, right, so it's either in that case both of them are below the x-axis, right, and then you can reason the other one as well. Okay, for this one, then obviously we're looking for where they are opposites of each other. Okay, right, so yeah, this is basically the basic conditions that you need to know, right, and then obviously also be prepared for any other situation that they can ask you to interpret, right.